Okay, so let's look at one more question that is similar to question number 32 of your sample paper, right? So the difference is only that we have now the different bias network, right? So, and the sampling process is same, that we are using the likelihood weighting, right? And we have given this bias network and the associated conditional probability table. These are the associated conditional probability table. And what we are doing is that we are sampling from this bias network, right, using this likelihood weighting, right? And these are the sampling that we are generating. The main point to take care in the likelihood weighting is that you will sample over non-evidence. What does it mean? That you will fix your uh, evidence, and after fixing the evidence you will sample over non-evidence. So what does it mean by evidence or non-evidence? So in the conditional probability, what we do is we find the probability of some event given the evidence, right? So this condition that we are under what condition we are finding this probability, so this is what we are calling the evidence. So if you see what we have to estimate here, this probability, right? And that means we have to find the probability that minus a given this condition. So this is what we are calling it as a evidence. Given a evidence, what will be the probability of minus a? Or you can say, like, given a condition, what would be the probability of minus a, right? So likelihood weighting, we are going to fix these evidence, that means b and d. So during the sampling we will fix this b and d. Now we are left with a and c. So we will sample over this a and c, that is the non-evidence, and we will generate these samples. And if you observe in the sample that has been generated from this process, you see that this b is throughout the sample is same, that is plus b, and d is also the throughout the sample is same. Now let's look at that how we are going to solve this probability, right? So this is exactly the same problem, right? The pattern is going to be the same. The only difference is that now we have the different bias network, so that you can practice such kind of problem, right? Okay, so the process is same. Again, you will find the weight of the each sample and the weight of the sample. And if you haven't seen that question number 32, I would recommend to go through that. So the weight of the sample would be the product over each evidence. So what you will do, you will find the product of the probability of the evidence ei given its parent of ei. So here it is ei, right? So let me first let's find out the weight of this first sample. So the weight of the first sample, that would be probability of the evidence. So evidence is plus b, probability of evidence plus b given its parent. So its parent is a, and in sample if you look it is minus a, right? So we are finding the weight of the first sample, so that will be minus a here, right, into probability of the second evidence. The second evidence is minus d, so this is the d and its parent is c, so that will be minus d given, and in sample if you look at c, that is plus c, so given plus c. So now what you will do, you will look at your table. So probability of plus b given a, so probability of plus b given a, right, plus b given a, that is 1 by 3. So that will be 1 by 3 into probability of minus d given c. So look at your conditional probability table, minus d given plus c. So minus d given plus c, that is 5 by 6. So here we will write 5 by 6. That will be 5 divided by 18. And if you do the calculation, what you will get is 0.277. Now, can you find the probability of the weight of this sample to, let me know what, or should I find it? Okay, let's do it one more time. So let's find out the probability of this sample 2, right? So that will be probability that evidence, the first evidence is plus d, so plus b, not d. So this one, right, plus b given its parent is, the parent of b is a. So you look at this sample S2, because we are finding the weight of this sample S2. So that is plus a. So we are going to write as plus a. Now look at the conditional table, that is plus b given a. So plus b given plus a, right? So that will be 1 by 5. Okay, so okay. Now we will have here into also, because we have two evidence, right? So that will be minus b given, so minus d, so minus d have the parent c, so that will be plus c here. Now what you will do, you will find the probabilities, right? So what will be plus b, that will be 1 by 5 into minus d given c, minus d given plus c, right? So that will be 5 by 6. So that will 5 by 30 or 1 by 6. So that will be 0.17, right? Okay, similarly, you can find the weight of this sample S3. That will be probability of plus b given plus a into probability of minus d given minus c. That will be so 1 by 5 into this one, 1 by 8. So that is be 1 by 40. That will be 0.025. Right. Now we can also find the weight of the sample S4. That will be probability of minus plus b given minus a into probability of minus d given minus c. So that will be 1 by 3 into 1 by 8. That will be 1 by 24, and we will have 0.042. Right. Now we have to estimate this one. We have to find the probability that. So what we are going to do, we are going to make use of these weights to find this probability, right? So probability that a minus a given plus b minus d. So you are going to condition over this. So all the weights will fall under the condition, and what we have to look under this condition to find this probability of minus a. So under this condition, find all those minus a, right? So here we will consider this sample and this sample. We have two samples, right? That is with the minus a, and this is sample S1 and S2. So that probability will be sum of the weight of these sample, that is S1 and S2, that is 0.277 plus sample of 4, that is 0.042 divided by sum of the weight of the all sample, right? So WS1 plus WS2 plus WS3 plus WS4, right? So let me know what's the answer for this, right? So the correct answer is okay, so you do the calculation, then you will find the answer for this is 0.625, right? Okay, that was the one question that is similar to this question number 32 from your sample paper. Thank you.